Good afternoon. Well, I'm going to start on this radio, FADA model 115. The other day I painted up, I used some sandpaper and the wire brush and cleaned these up and put the handles on here, and I made another drawer off camera up there. The one on the left is the tubes, and the one on the right has other mixed items in it. So they came out, I think, pretty good. Painting them black is the easiest way. They seem to be brass, but I'm not going to fuss with it and trying to get it down to a shiny brass. They were painted originally, so we'll just clean them up and paint them again. I was only able to find one schematic, and it's always the ones that are not clear. For the model 115, also on the same site, the FADA model 1000, which has an extra tube for the RF amplifier, but it is different. It uses a 35L6 instead of a 50L6, and it has the extra tube. And it apparently uses a 3-gang tuning capacitor. I mean, filter capacitor. And here it's just a 2-section. It looks like 30, but I can't make out that one, so I'm going to say they're both 30. And I guess it's this one right here. I'm primarily evaluating now and see what I have to do. At first I didn't think there was an electrolytic in here, and it was removed because there is a wire right here that goes to ground. It looks like a cloth covered wire. So I had figured, well, maybe there was an electrolytic there, but after examining this, it says dry electrolytic on the other side here. It's upside down, but you can probably see it. And it looks like it's 2-section. It's really hard. I got to get in here. The only thing I don't like is it's electrocution radio. The switch, just like that other radio I repaired for Bob there, the tuned RF, it goes directly to the chassis. See the braid right there? And this is one side of the line cord, so it's switched. I don't know why they always switch. The part that goes to the chassis, I have no idea why they do that. In every radio I've ever worked on, the switch part should be over here, not on here. But what I'm going to have to do, now this cord is fairly good, but it must have been replaced at one time. I have to put a polarized plug on this thing and cord and make sure the neutral is going direct to the ground, and I'm going to have to remove this and switch the wires so I'm turning on and off the hot side and ground the neutral. In other words, bond it to the chassis, and it'll be bonded all the time. It's congested in here. I can't tell what this is. I think that's a resistor, but it's got all wax all over it from these 2 capacitors here. So, like I say, I'm evaluating this now, and will be working on it very soon here. I was told to leave this paper in. I think it looks like hell. But I don't know. I still say it don't belong there. The only thing is, it's got these 2 plastic rivets that just push you can pop them out, and you can snap them in with your fingers, and they go into the metal. It almost looks like it's an add-on, but you see how it's overhanging here. It just don't, it looks like hell. I know. I have not taken the tubes out or tested them or anything. This capacitor here broke off the loop, and here it is right here. Here's the hard wire right there. So I marked this so I know it goes up, and the tuning capacitor goes here, and the wire that comes out of the chassis goes there. So it is the two wires that go to the loop. So I know where they go. In case they break off, I'll know. Only one wire was hooked up on here anyways. The other one had broken off. It uses a field coil speaker, which it shows here on the schematic right here. And this is a 30 microfarad. And I can't tell. That's either a 20 or a 30. So I don't think I'll have a problem putting a 33 in both of them if I have them. So to start with, for safety, I'm going to have to take out this cord. And it was replaced at one time anyways, because it looks like mice type of soldering work. When you have bad eyesight, you're lucky to be able to get any connection at all. Some of these guys make it look easy with the solder suckers, just pulling the wires right off, but it don't work that easy. I can spend as much as a half an hour trying to get clean one terminal off. So, again, hook and pinch is the way I go. On this, I'll try to clean this off as much as I can. I'm going to just cut this wire off, but I'm going to leave the tails on so I know where they go. And I'm going to take and secure the neutral side directly to the chassis and bond it. So it'll be a safe radio to run. It shouldn't be too hard to restore as long as the IF cans are good, the field coil speaker's good, and the oscillator coil is good. Everything else we can deal with. I want to touch base on one thing, outside foil. Now there's several videos on the outside foil. You're familiar with the band on the older capacitors here, this is one I removed out of the FADA 115. It don't make any difference. I can't tell the difference. If you look at the display here, you're picking up a little interference now because the gain is up quite a bit. We'll probably reduce that just a little. And if I'm trying to do it without getting my hands in the way of the lens, you see it's moving about, I'd say about 3 divisions from here to here if you look at it. Okay? Now, if I take and reverse this, so I'm having a heck of a time getting the clip lead, the ground lead, this clip on this thin lead, and my eyes just don't work. Okay. No difference, see? So it doesn't make a bit of difference. There is no difference wherever you reverse this. There is really no such issue with outside foil on the new caps. If there was, they would be banding them, you know. I have never, in all the years that I have done capacitors, back in the days when orange drops used to have the outside foil marked on them, I'd put them that way. So if the orange drop, for instance, had the band on the right side as I'm looking at the capacitor, I would put that the same direction. On these, it don't matter. Just put them in. It doesn't make a bit of difference. It's proof right here on the scope. I can reverse it, which I just did, and makes no difference. Makes no difference whatsoever. That is not an issue with, I just reversed it. Same thing. All right? So, the guys that have these videos up there with outside foils, unless I'm doing something wrong here, I'm using a scope probe R times 1, and you know, unless I'm doing something wrong, it makes no difference. So don't worry about it. Just put them in. Don't worry about it. The only thing you got to worry about is electrolytics. Make sure they go in the proper polarity. Okay, so I'm going to work on replacing a capacitor right now in the FADA 115. Okay, this is supposed to be a 0.03. It goes from the plate to the cathode. It's a high frequency bypass, so you don't get squealing and everything. There is no 0.03 marked. It's marked C10-38, and there's the part number right down there. Okay, so we're going to replace it with a 0.033. Now that's a little high in capacitance for a bypass. What it does is it takes the highs out of the radio. But this is not a high fidelity machine, so it doesn't make any difference. I mean, it's just standard broadcast, and if you can get 5 kc out of the audio, you're doing good, and that's normal. Basically voice and music, but nothing. In other words, it's not FM, so you don't really have to worry about it. So we'll put this in. It goes from pin 3 of the 50L6 to pin 8 of the 50L6, which is the cathode. The plate is number 3. I have to put these reference notations down here because they don't mark the pin numbers. On these older schematics, they're very difficult. You have to drag the tube manual out all the time, and thank goodness I got that. It goes here. I clip it long, but I'm going to try to solder to the terminal. I may only be able to tack it though. And it goes to pin 3 here, which it actually came right off. It wasn't soldered very good, so the lead came right off. And here is the lead right here. So it just fell right off. After I cut it off the capacitor, the whole thing just came right out. So it goes there. But I need to get this electrolytic out. I need to get these capacitors out and replaced. And this is a resistor. It's just covered with wax right now. And I think this is a 1,000 ohm resistor, but I'm not sure. Or it could be a 100 ohm resistor. It's hard for me to read that. I'm going to have to go into the schematic and try to read that, what the value is, and then put a meter on it and see what it is. So what I imagine is it's going to have to be changed. But this electrolytic has got to come out of here, and these two have got to come out of here too. Now I won't be starting on this tonight on camera. I'll be doing some things off camera, all replacements and capacitors and stuff. I don't do them on camera. I have to get my face right in here. I have to use all kinds of magnifiers and everything else, and it takes me 10 times longer to recap and change the resistors if necessary than the average guy because of my eyesight. So it takes me a very, very long time to do this. So the video would be a week long. If I was to record everything. Can you imagine a video 1 week long, one continuous week? Oh, no! Okay, this is the electrolytic I had taken out. It's a 40 and a 40. So here it says, plainly says 30 here. I can't tell. That looks like a 20. So this was replaced, but it looks almost like factory, but at this end, no, it looks like some kind of a soldering job that I would have done and actually still do. But you can see the end of this. I will stick the meter on it but I don't expect it to read anything. 6.5 microfarads and 3.5 microfarads is what it went down to, according to this meter here. Not that I'm going to use it, even it sure as heck ain't going to test good, that's for sure. So 40/40, it calls for 30. So if I can put 2 33s in there, that should be good. But it was replaced because you can see down on the chassis there where I clipped the wire off. An attempt was to solder that onto the chassis, and they did do that. I would have to get my American Beauty iron out or my soldering gun in order to solder that down. But because I'm going to be replacing them with radio leads, because that's most of what's available these days, I may put them in a different way with a terminal strip. But first of all, these two have got to come out. But I don't want to take too much out of here now. I'm making notations as to what I'm doing here, but you don't want to shotgun and take all the caps out at once, and then you'll screw up every time. At least I will. So we do try to do one at a time, and this time we've got the electrolytic out and the audio plate bypass capacitor out. So before I put the a new audio plate bypass cap in, which is, as I said, does not matter on these new ones. It's not an issue with outside foil. I proved that on my scope. Before I put that in, I want to check the resistors that are around here because it may be difficult for me to get at them later. So we're going to do all this off camera. I'm just basically giving an evaluation and a small part replacement now. The last thing I do on this is the switch and the power cord. And I did not test the IF cans. I did not test the oscillator coil, nor the speaker or the speaker field. So I'm kind of gambling on that. But the radio is a collectible, so even if those items were bad, I could probably get something for this radio. I know I'll never get $400 for this thing. Not old 64 goat. Old 64 goat might not even get $10, $20, or $30 for it. All right. Okay, this is all I'm going to do tonight. I got the plate bypass capacitor in, the 033, which is the closest I can get to 0.03. This is a 0.01 to the grid coupling capacitor to the output tube. That's got to definitely be changed. They're all going to be changed anyways. From the plate of the 35Z5 to chassis, it's in effect a line bypass capacitor. I put in a safety cap right here. And I got to put the electrolytics in, but before I do that, I got to change this 01. I got to change this 500,000 ohm resistor, which is 470,000 on the updated schematic for the FADA 1000, which is not this radio, but I can read this schematic clearer, and that schematic calls for a 470K resistor from the grid of the 50 L6. In this case is the 35 L6, but this one uses the 50 L6 to ground. So that reads about 900 and something, and it keeps climbing, so it's probably open, and I'm just reading through the capacity here. So I got to change that to a 470,000 ohm. When I get that done and change this, I can put the electrolytics in. I cleaned off the power switch terminals and took off the ground, switched, and actually use it to hook and pinch onto the safety cap, because the safety cap has very short wires. So we'll continue on this as we go along, but this is the end of part 1 of the restoration of the FADA Model 115. Stay tuned for part 2 coming to a computer near you in the very near future.